So in the notes, in the first section, we wrote this formula. We started off with a ratio, and then we found that if you solve for arc AB, this is what you get when you solve for it. And so this is the formula that we're going to use. So if you have another color of pen or a marker or anything, I just want you to put a box around that this is the special formula that we're going to use. If you have a good memory, memorize that. If not, make sure that that's like, that you draw attention to this part in your notes. Because this part is a little bit easier to use than the fraction part that I wrote above it in the notes. Because this is where the arc length itself is isolated. So this is the arc length, this is the measure of the arc. And if you need to write down a little note to yourself to remember the difference between those, that would be fine to put a little description there. So this is the length of the arc. This is the measure of the arc. So it would be a degree measure of the arc, length of the arc versus the measure of the arc. When we talk about the sector area, we're going to be using this formula because it has the sector area isolated. And then the same thing here. This is the area of the sector. This is the measure of the angle of the sector. So the degree measure of the sector that they're talking about. So since that notation is in two different places, we don't want to get those places, we don't want to get that notation mixed up. We want to make sure we understand which is which. Okay. And then I don't remember where I left off in the notes. I know that I did a few of these in the table, but I just want to make sure that we can finish it. So can somebody tell me what markings I should have filled out here in the drawing? Did I have everything filled out in the drawing? Yeah. So I said this was a right angle, so it's 90 degrees. That makes this 90 degrees over here. I had that filled out. And then if these central angles are 90 degrees, that means the arcs are 90 degrees as well. I had that filled out. Yes. Okay. And then I said this whole thing over here is 180 degrees. So if this is 21, that means that this is 159. And then if this is 21, this is 21. And if this is 159, this is 159. Okay. So all of that was filled out. And then how far into the table did I go in the video? I went to 1, 2, and 3? Yes? Okay. So now we're on to number 4. When we get to number 4, is number 4 a minor arc or a major arc? Minor arc or major arc? It's a major arc. So just a reminder, a minor arc only has 2 letters with the notation, and it's going to be less than half a circle. It's going to be less than half a circle, so less than 180 degrees. When we get to one like this that has 3 letters, this is going to be a major arc. And it's going to be more than half of the circle. Or it could be exactly half of the circle. Sometimes they do that too. So from A to R to G, A to R to G, how many degrees is that? $249. Okay, so the arc measure of that is 249. Okay. And then what do I do to find the arc length? Same formula as last night. What do I do? 249 over 360 times what? 2 pi 6. So the radius of this problem must be 6. They told us the diameter is a length of 12. If the diameter is 12, that means the radius is 6. Okay, so 2 pi times the radius. And then when we type this into our calculator, they told us in the problem to fill out the table using exact measurements in terms of pi, which means that if we're writing pi on our paper, we should not be plugging it into the calculator. So we're going to type in 249 divided by 360 times the 2 times the 6. I'm not typing in the pi. And if you guys multiply all of that, what do you get? Awkward silence. Anybody? You guys all have calculators? Lots of calculators out there. What do we get? 8.3. Perfect. Okay, so we're going to say 8.3, and then we're going to stick a pi on there. So this is a good decimal to be able to write down. It's okay that it's a decimal, not a fraction, because it didn't have to be rounded. It was a perfect decimal that we wrote down. So 8.3, and then what are the units? Centimeters. Okay, that's a length. All right, and then if we want to find the sector area, how do we do that? Okay, times pi r squared. Okay, we're going to do the same thing. So 249 over 360 times, we're not going to type in the pi. We're just going to do the r squared. And what do we get? If the instructions told you that you could round the answer, write a decimal answer, then you would type the pi in, and you would just write a decimal answer for the whole problem. There's a pi symbol in the calculator. Yeah. So what do we get for this? 24.9. So this would be 24.9 pi. And what are the units for this one? Centimeters squared. Okay. All right, next one says arc AR. So from A to R is 90 degrees. So go ahead, take a moment, figure out what the last two parts of the table should be. Gonna give you guys maybe like 2 minutes or so to fill in those last two spots in the table. All right, number 6 says, what is the approximate length of arc ARG? So the whole length rounded to the nearest thousandth. So here they're not just saying write it with a pi in it, they're saying actually type the pi into the calculator, tell us what the overall length is. So for number 6, they want the approximate length of the arc, they want the arc length. So we're going to go to ARG, we're going to go over to arc length, we're going to take 8.3 pi and type that into the calculator and see what it gives us. So 8.3 pi, go ahead and type that in. So 8.3 times 3.14, it's going to be somewhere around 24. Some number that's nearish 24. Nope, you're going to use the pi button. So what do we get? 26.075 centimeters. Okay. Then it says, look at TG. What is the approximate area of TG rounded to the nearest thousandth? So we're going to go to TG. We're going to go over to the sector area that you already found, and we're going to take the answer from that and plug it in. So plug the number in, plug the pi in, see what that decimal is. 6.597, is that what we got? 6.597 centimeters squared. Okay. Everyone comfortable with those answers? We could get those? Yeah.
So I have a question about the second area. I've noticed that our answer always put like the last digit of the original length type as like you put the last digit like behind the decimal. So if you have like 180 that you put in, it would be like 18, but if it was 21, it would be 2.1.
So you noticed, say it one more time. It might just,
measure is 249. The
Uh-huh.
answer is
24.9.
And then like with this one, you put in 90 and you got 9. So you would put the 0 behind the decimal and it would just come out as like a
Oh, so I'll tell you the reason for that. The reason that it's doing that is because 6 squared is 36, and the 36 is canceling out with the 36 of the 360.
Oh.
It's only doing that because of the 6 squared. It's not like it's not going to do that every single time. It's good that you noticed that though. So there is a power of 10 happening in this problem specifically, but it won't happen in every single problem. Does that make sense? So you guys are noticing something mathematically that's actually there. It's just not there always.
Okay.
Yeah. Good to notice that. Yeah. And that's because of the 6 squared. 6 squared and the 36 were canceling out. Yeah. Okay. We're going to go ahead and start looking at the assignment and practicing some problems like these, and then some problems where they ask you to solve for things that are a little bit more puzzling than this, because these are pretty straightforward. Just use the formula. So now, this is all that we are learning before we take the quiz. So the notes that you have so far, you're going to want to get into a folder, and the folder that you have is what you're going to be using on the quiz. And we're going to be taking the quiz on Monday, which means you are not going to have a video for homework tonight. But you are going to have some of these problems to do, and then you're going to have your quiz review to work on. Okay. Quiz Monday. Yep. All right. So let's go ahead and look at the first section of problem. So these are not quite arc length and sector area. These are just practicing finding some angles. So in here it says the measure of angle 1 and the measure of angle 2 are equal to each other. So this angle and this angle are the same. And then it says the measure of angle 1 is 9x plus 5. And the measure of angle 2 is 4x plus 35. Okay. So what could we do if we want to solve for x and then find those measurements? Yeah, we're going to set them equal to each other. And say it again.
You wrote down right.
Oh, plus 35. Now what should I do? Subtract the 5 and subtract the 4x. So we get 5x equals 30. Okay, x equals 6. So x equals 6 is one of the answers. And then what can we do with that?
Plug it in.
Plug it in? So if we plug in 6, what do we get? Say it again. You get what? I just can't hear you. 59. So you can do it in either one of them. It doesn't matter. So 9 times 6 is 54 plus 5 is 59. Or 4 times 6 is 24 plus 35 is 59. So either way you do it, 59 is good. Okay? And then how could we get another answer? Are there any other angles we could find?
P.
Angle P.
Yeah, it's the same next to the other side.
Yeah, so this is where we've got like an X happening in the circle, and we've got these two, so we've got this side, which means we've also got angle P, which is the other side, right? So what do these two add up to be? 118, so that means the angle P is also 118, okay?
3 and 4 are congruent.
Yeah, 3 and 4 are going to have to be the same as well. So these are angles 3 and 4. Those are going to have to be the same. Okay, so we could say that those two angles make up a straight line. So if P is 118, how could we find angle 3? Subtract it from 180. So 180 minus 118 is 62. And so that's 62. Okay, so measure of angle 3 is 62. Measure of angle CPB. From C to P to B is 118. Arc AE. Arc AE. What would this arc be? 59. So this is a central angle, so the arc and the central angle are exactly the same, so it'd be 59. Okay, what's the measure of arc EC? E to C. So 59 and 62 is 121. Okay. The measure of the arc from C to B to E. 118, 62, and 59. What is it? 239? Okay. All right, so that wasn't really using the formulas, that was just thinking things through. Okay, so here's where they ask us to start using our formulas. They're asking us to use the arc length. The first 3 problems they want us to write the answer in terms of pi, and then the second 3 problems they want us to do some rounding. So I'm going to just divide this in half. So the first 3 we're going to do pi, the second 3 we're going to do decimals. Okay. All right, so it says that for the first one we have a radius of 12 centimeters. We have a central angle of 80 degrees, which means we have an arc measure of 80 degrees as well. And so the arc length AB is going to be the measure of the arc divided by 60, the measure of the arc is 80, times 2 times pi times what? 2 times pi times 12, okay? And then since we're writing our answer in terms of pi, we are not going to type the pi in the calculator because we're going to write it on the page. So I'm going to do 80 divided by 360 times 2 times 12. And what do I get? Yeah, 5.3 repeating. I shouldn't round this if I need to write it down, so what should I do instead? Turn it into a fraction. 16 over 3. So I'm going to say that this is 16 over 3, and I still have to add a pi to my answer, so I'm going to stick the pi on there. And what else am I missing? Centimeters. This is a length, so we're going to put centimeters. Okay, what am I going to do for number 10? How do I do number 10? I want decimals this time. So I'm going to say arc AB is what divided by what? $60 divided by 360 times 2 pi 7.3. And what am I going to plug into my calculator? And I'm going to plug all of it into my calculator. I don't leave anything out this time. So, and this is because they want a decimal answer. We're plugging the pi in. So 7.64, and then the last number can be rounded up. So 7.645. 7.645 centimeters. Okay, so we're going to start with this part. 7 through 12 is arc length. And then 13 through 18 is sector area. And they do the same thing where the first 3 they want you to do with pi. And the second 3 they want you to do with decimals. So right now we're going to work up to number 18. And then we're going to pause because they change how they want you to do it with the instructions. Okay, so we're going to work up through number 18 and then pause. All right? So it says find the measure of arc AB. And then if you look in the problem, it gives you the length of arc AB. So if we write the formula out, the length of AB equals the measure of AB over 360 times 2 pi r. That's the formula. So if we plug in the information we have, then the 12.56 goes right here. What we don't know is the measure of AB, so I'm going to go ahead and put an X right there because it's easier to write repeatedly. And then we also know what the radius is, the 12. So 2 pi 12. Does that make sense? So we're trying to solve for this x right here. So we have a divide by 360 that we need to undo, and we have a times 2 pi 12 that we need to undo. What would you guys like to undo first? We want to undo the 2 pi 12? Okay, so we're going to divide by 2 pi 12, and we're going to divide by 2 pi 12. Now we have to be really careful about how we plug this in, because if you type in 12.56 divide by 2 pi 12. If you type it in like this, you're going to get this problem wrong because your calculator is going to divide it by the 2 and then it's going to multiply by the pi and the 12. So for us to get this right, we're either going to have to put parentheses around the bottom or we can just use the fraction function on our calculator. So how I like to type these in is to do alpha y equals and type this in as a fraction, because then I can put all the stuff on the bottom of the fraction. So 12.56, and then I can type in 2 pi 12, and then I'll actually get the answer right. It's not because I care that the final answer looks like a fraction, it's because I want all that stuff on the bottom. So this is the correct decimal. I'll show you guys what the wrong decimal is. 2 divided by 2 pi 12. That's the wrong decimal. Does that make sense? Okay, so the first one is the one we wanted. We've got that. Okay, so we divided by 2 pi 12. And so now we have that decimal. I'm going to go ahead and write it down. I'm just going to say 0.167 equals x over 360. And now what do I need to do? Yeah, just times 360. Times by 360. Okay. So if I just hit times, then it's going to pull the previous answer for me and multiply that previous answer by 360. So 59.969. So I'm going to write this down. X is 59.9. 69 is followed by a 5. So if you have 69 and you have to round it up, what does it round up to? 70. So 69 rounds up to 70, so 59. I usually put that last zero just so I'm still rounding to 3 decimal places. Yeah. 59.970. Let's go ahead and let's try the next one in the next set of problems too. So the next 2 problems are going to work similar to this one using that same formula. If we look at problem 22, it's the same idea. It just uses sector area. So same thing here. We have, I'm going to write the formula up here. We have the area of AB equals the measure of AB over 360 times pi r squared. And so again, the instructions are asking us to find the measure of AB, and they gave us the area. So we're going to say the area equals the unknown measure divided by 360 times pi radius squared. Okay? And if we're going to get the x alone, we have to divide by 360, but we also have to multiply by pi r squared. And so we're going to have to undo both of those things. Which one would you guys like to undo first? The pi r squared. So we'll divide by pi 14 squared. Divide by pi 14 squared. Okay? So I'm just going to make sure that I type that in like a fraction. Alpha y equals 120 divided by pi 14 squared. And if you're doing this correctly, you're probably going to get a pretty small decimal every time. And then when you multiply that very small decimal by 360, then it's going to become a bigger number that makes sense for a degree measure. But before then, you should have a pretty small decimal. If you have a big number here, it means you probably typed something incorrectly. So 0.195 equals x over 360. And then what do I do? Times 360 times 360. Okay. 70.158. X is 70.158 degrees. Okay, make sense? So now we're going to work up to problem 24. The problems after that are just using the formulas, and I'll help you guys with those so we can try a couple of these multiple choice problems. But go ahead and do through 24 first, and then we'll pause and we'll do a few of the next ones. If you feel like you're understanding these pretty well and you think that you can do the multiple choice on your own, you're welcome to try them. But if you start to try them and get frustrated, feel free to pause. Okay, so we're at least going to go up through number 24. So when we get to problems that are like these multiple choice, the multiple choice are not like the previous problems. The previous problems were like doing the same thing over and over. The multiple choice, they give you specific pieces of information and then you have to find something else. So the same approach may not work every single time, but I'm going to tell you a method where it will like, this is a good way to get them started, and then usually it will kind of help you do the problem. Okay, so what I like to do is I look at the wording of the problem and I figure out which of the two formulas I'm going to work with. So if you look at number 25, it says length of the minor arc. And since it says length of the arc, that tells me I'm going to use the arc length formula. Because it said length of the arc, it didn't say area of the sector. So then what I do as soon as I see that wording is I write down the formula for arc length. So I'm going to say arc AB is the measure of AB divided by 360 times 2 pi r. And then once I have the formula written down, I start to fill in all of the information I know from the problem. Okay? So it says in this circle below, the circumference is 72 millimeters. Can somebody tell me what circumference is? It's like the perimeter of a circle, right? The perimeter of a circle. The perimeter of the circle is 72. Does anyone know what the formula is for circumference? It's not pi r squared, it's 2 pi r. Okay, so the circumference is 72, so we're going to say if the circumference is 72, that means that 2 pi r is 72. Okay? And then it says the length of the minor arc is 6 millimeters. So we have some information that we can fill in. We have the length of the arc is 6 millimeters. We have that the whole circumference is 72. So I'm not going to fill in just the radius. I'm going to take this entire piece out and I'm just going to put 72 in for that entire piece because this whole thing is circumference. So I'm taking that whole thing out. Then it says, what is the measure of the angle CKA? And the measure of the angle CKA, we're going to have to find that because that's not the arc that they're talking about. So we're going to find the arc first and then we're going to come back. Okay? So our formula talks about arc AB. For this particular problem, we're going to be finding arc AC. But it still kind of works. Okay? All right, so I'm going to label this as X. This is the arc that we're finding in our problem. They want us to find something else, so we're going to go ahead and find just the arc in our problem first, and then we'll continue and do the rest of what they're asking of us. So I'm going to say X over 360. Okay. So are we comfortable with where I got the 72 from and where I got the 6 from? We comfortable with that? Are we comfortable with me labeling the X here and putting an X here? We can see what that is. Okay, and the X is a degree measure. Okay, so what should I do to solve for X? Divide by 72. Okay, 6 divided by 72 is, 0.083, okay. 0.083 equals X over 360, okay, and then what should I do? Okay, so times 360, I get 30, okay. I'm not making any conclusions about the answer yet because the answer asked me to do something different than the length of the arc, okay. So what I'm going to do is I'm going to label this arc right here, I'm taking away my X, this arc right here is 30 degrees. Okay, now if this arc is 30 degrees, what do we know about this angle right here? Also 30 degrees. Okay, now the problem, let's go back to what they were asking. They said, what is the measure of angle CKA? So from C to K to A, that's this angle right here. Now we've learned something different about this angle. This is a central angle. This is an inscribed angle, and it is what? Half. It is half of the intercepted arc. So if the arc is 30, what's the angle? 15. So our answer is actually A. Okay. The wording for 26 tells us the length of the arc. The length of the arc. So what formula should we use? The arc length formula, right? Okay, that's the wording of the problem. Okay, the next one says, blah, 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 blah. What is the length of the arc? What formula are we using? Same formula, arc length formula again. Okay, if we turn the page, this one says, in the circle below, the length of the arc. What formula are we using? Arc length again. Okay, let's go ahead and solve this one. All right, so what information do they give us? So they tell us the type of formula we can use, the length of the arc, so we're going to use the arc length formula. And then they say the length of the arc is 6 pi. So where do I plug that in? Do I plug it in here or here? Which one do I plug it into? You might need to look at your notes. For right here, it says the length of the arc is 6 pi, and which spot can I plug that into? The left one or the right one? It'd be the left one because the left one is a length, the right one is a measure. So they told us this is a length. The other one is going to have to be a degree measure for what the measure of the arc is. Okay, so this is a length, so we're going to put the 6 pi right here. Okay. The measure of COA is 120. So they're telling you 120 is the measure of the angle. If it's the measure of the angle, what is the measure of the arc? Same thing, 120. Okay. They're telling you the length of the arc is 6 pi. So the measure of the arc is 120, but its length is 6 pi. And they're asking you to find the radius. All right, so we're going to plug this in 120 over 360 times 2 pi r. They're asking us to find the radius. So right now we have 120 over 360 times 2 pi times r. So all of these things are being multiplied by the r. How do I solve for r? Yeah, I could divide this and see what this equals. Yeah, so all of these are multiplied together, and they're all multiplied by r. So how do I undo that? divide. And you don't have to do it in multiple steps. You can do it all at once. It looks like a mess, but your calculator can handle it. So we can divide by everything in front of r all at once. 120 over 360 we can get rid of. 2 pi we can get rid of all at once. We can leave r alone. And then over here we can do the 120, we can do the 360, we can do the 2 pi. So it looks like a mess, but if we type this in as a fraction, our calculator can handle this just fine. So I'm going to do alpha y equals, and what am I going to type in on the top of the fraction? 6 pi, only a little bit on the top of the fraction. Now on the bottom of the fraction, what should I start typing? You can type it in as a fraction, or how else could we type it? Divide, yeah. So you can do 120 divided by 360, and then what should I type? Yeah, times 2 pi. And you can hit the times button, or you could do a parenthesis for that. So times 2 pi. Yeah, so if you type this in as a fraction, it's really easy to type. All right, so we type that in, we get 9. Radius is 9. Boop. Okay. Now, this one is crazy because it starts and it says the length of the arc. All right, so we're starting with one formula. But then it says what is the area of the sector. So what do you guys think this problem is doing? What do you guys think this problem is doing? Yeah, you're probably doing the problem in 2 parts. You're going to do both formulas. You're going to do one formula first, get some sort of information from it, and then you're going to do the other formula second. Does that make sense? You're going to use both formulas. Okay, so for that section that has the multiple choice problems, I want you to, what numbers did we do? We did number 25 and number 28. I want you to choose one more problem to do. Okay, so you can do 26, 27, or 29. 26, 27, or 29. You choose one of them to do. If you do all of them, it's extra credit. Okay, so choose one of those to do. And then I'm going to have you guys do so here's what we'll write this. I'm going to write this down on the top so that we can understand what we're doing. So choose 26, 27, or 29. So choose one. 26, 27, or 29. Choose one of those. And then I want you guys to do number 30 and 31. So you've got 3 more problems to do. Sound good? 3 more problems to do? Okay. Now, as far as getting us prepared for the quiz on Monday,